Okay, I'm gonna make yet another video about simplifying code. In this case, it is mostly a question of just choosing names. So, uh, at least the first part of this video is going to be there's no rocket science here. There's no advanced programming techniques that you don't already know. Maybe I'll slip in a few of those at the end, but for the start, I just want to show how we can take some code, again, student code, as far as I can tell, working code. So this is like the best place to start. We have code that like does the thing. I think it does it right. But if you can see this code on the screen, it may look a little impenetrable to you. It certainly does to me. Mostly just because the lines are so long. So like down here, especially we have several layers of indentation. I don't know if we actually look. We have four loops, four levels of loops, plus an if statement. So we have like 5 levels of indentation. A lot of these lines that are indented quite far are also quite long, and that mostly just seems to be because a lot of these variable names are pretty long. And they have another characteristic, which they're long, and they have common prefixes, which makes them extra hard to read. Because like just looking at like cur shape bounds and cur shape bounds check, I have to read however many characters are in curve-shaped bounds before I get to the difference in the two names. That actually makes it harder to read rather than easier. So oftentimes we encourage programmers to use variable names that aren't too short, because if you just use X and Y and A and B all the time, it's very cryptic, right? If we call this function C instead of collisions, it would be much less understandable what it does. Like at least from the original name, collisions, we have some idea what this function is doing. And obviously in the context of a larger program, it would make even more sense. But some of these names, by being long, is actually hurting things. So I want to just go through and show a few ways to reorganize or just change some names basically, and probably make this code a little bit easier to read. So I'm going to actually, I think what I will do is I will pop over. I'm going to copy this whole thing. We'll make a new file, orig.js, paste it in there. Should have done this in advance. We'll save that, close that editor, and come back over here to foo.js, and I'll do my work here. But then at the end, we'll be able to compare. Okay, so the very first thing, there's a bunch of ways I could tackle this. I kind of want to, I'll start from the middle out just because like these are deeply nested N words, very long. And there's a couple things. Actually, maybe I'll start farther out. So we'll start out here. So we've got this array shapes. So that's a good starting point. Okay, like so far we're good. We're getting the collisions between a bunch of shapes. The plural suggests that maybe it's an array, and we see in fact here we're writing a loop over that array, another loop over the same array. So shape num is fine. I'm going to go ahead and use the rename symbol to just call that S1, because this is just an index, and index variables don't need long names. So I could even just use I or J, but the fact that we have these two nested loops over the same array suggests that these are kind of related. And then following the same idea, I'm going to rename shape nums check. I kind of feel like the check was just tacked on to make this name different somehow, but like I said, having that long common prefix actually makes it harder to read the code. So I'm going to call this S2. And so now these two loops at least are kind of easy to see that we've got a loop S1 going from 0 to less than the length. So that's our canonical loop over all of the indices in an array. And then S2 starts at S1 and goes up to length. And that might be not quite as familiar to you, but it is also a pretty common pattern where this is the first loop is looping over all of the elements, and the second loop is looping starting from whatever the first one is on. So that's going from the current item to the end. So we're pairing up elements of this list, but not so like the 0th element, and then it's going to be the well, the 0th and the 0th, and then the 0th and the 1st, and the 0th and the 2nd, so all the way up to the end, and then the 1st and the 1st, the 1st and the 2nd, the 1st and the 3rd, up to the end, 2nd and 2nd, 2nd and 3rd, 2nd and 4th, so on. So you can see it's going to do every pair where we don't consider two pairs in different order to be different. All right, so now that we see that pattern, we can actually look at what is this if about. So this if is checking only actually, this whole if is like this, basically this whole, the rest of this body of these loops. So we only do something if S1 is not equal to S2. Well, we know it's going to be equal the first time through because we just set it to be equal, but otherwise it's not. So we can actually get rid of the if and a whole level of indentation by, instead of starting S2 on S1, start it at the one right after it. So now we delete those two lines, format to get the indentation fixed. And so now we have a loop. S1 is going over all the indices. S2 is going over all the indices that are greater than S1, since it starts at 1 greater. And you might worry that that would go off the end of the array, like when S1 is the biggest possible index, i.e. the length minus 1, then S2 would be 1 greater, which is the length, but that would just mean that this loop would never run because the condition would immediately fail, and that's actually fine. Okay, so the auto renaming of those variables has reduced the length of some of these lines, so we can see that current shape bounds is getting get bound of object. I don't know what that method does, but it looks like it, based on the names, I assume it returns an array of something, and we can see, in fact, we're looping over what looks like an array, so yeah, that's probably an array. And current shape bounds check, same problem with these big common prefixes, but we can see we're getting the bounds of essentially our first shape and our second shape of this pair that we've just produced. So I'm going to rename this S1 bounds and rename this S2 bounds. And actually you can kind of see what I'm doing here is I'm using, instead of common prefixes, I'm using common, well, I mean, the S part is the same, and the bounds, the suffix, common suffix, shows that these two variables are related in some way. Like they're kind of the same thing, just for two different ones. And then using S1 and S2 kind of establishes the connection, in this case, between these index variables, but it's kind of this is the index of the shape, this is the bounds of the shape. These things are all tied together. Okay, so now we get to the inner loops, which are even harder to read, and we're, like I said, you know, this if we go back a step or two, like this line is a monster because we've got cur shape bounds index, cur shape bounds index again, less than cur shape bounds, which is almost the same name, just it doesn't have an index on the end, and then cur. So like there's a lot. Cur shape bounds we have to read 4 different times in this one line. So can I put, nope. So I'm going to redo my rename, S1 bounds, S2 bounds. Okay, so that didn't fix that line much, just fixed one of them. But now we've got these 2 other loops. This one is looping over the S1 bounds, and this one was open over the S2 bounds. So I don't really know, but these are bounds. I don't know exactly what that is, but I'll just call this B1. That line is so much easier to read now. Okay, we've got an index variable, and the fact that the variable name is so short kind of tells us, like, oh, this is just a loop variable. It's going to be used maybe to index into some stuff, but it doesn't have a lot of meaning, and so it doesn't need that big a name. Same thing. So now we have an index that's looping over the length of the bounds of shape 1, and the bounds of, another one for the bounds of shape 2. And now I'm going to delete this comment. It's not doing much for me. And now we can look. With the shorter names, it's a little easier to see that there's a bunch of S1 bounds, like that expression occurs 1, 2, 3, 4 times, and this S2 bounds B2, well, it only occurs twice, but really what we can see is we're getting the element of the arrays that we're looping over. So just for grins, I'm going to call that, what is that? So that's the particular bound of S1. So we'll just make it the same name, but without the plural. So that's another trick. When you have variables that are named plural because they're arrays, then one element of that array is the same thing, but without the plural. And so we, like our normal grammatical intuitions from having spent our whole lives speaking human languages, helps us out. Okay, so I've just declared those two variables, and now everywhere their values occur, the expression occurs, I can replace it with s1 bound.x, s1 bound.y. Just delete that. So that doesn't make it a ton shorter, but it gets rid of some of the noise of, all extra punctuation is also always a little bit harder to read. It's nice to just see names. So like S1 bound, okay, that's the particular bound from shape 1 that we're currently talking about. So these bounds appear to be points, and we're computing some distance, as you may recall from various numeric exercises. So I'm going to go ahead and actually take this whole expression, copy that down here, go ahead and write our friend, the distance function. And this one I'll just write in terms of like P1, P2, because that's what these really are. The fact that they're bounds and that other, that's fine, but from the point of view of distance, they're really just points with an x, y value. Actually, I can show you. We can use the rename trick. If we give the names that match the code we just pasted in, we can then rename them to the names we want here. And the reason I use these slightly more generic names is because this is a very generic function. And so it's nice to just like make it short, to the point. And we do this in shorthand form here, so I don't have a return statement. And then this is a little bit of an advanced thing, but I've left it on some, I guess on the pull request for this code I've pointed out. Although I've made you write it a bunch of times, there's actually a function in math that does this whole like square, like this distance function basically for us, or it computes the hypotenuse. That's what hypot stands for. So it takes care of the squaring. Oh, look, this one didn't change because I didn't fix it, I think, up here. It won't matter in a second, but so we can change that to P2. Oops. P2. We don't need the squaring part, and we don't need the addition part. So hypot basically does the same thing. It squares its two arguments, adds them together, and takes the square root. And the reason it's better to use that, get rid of those squiggles, is that not only is it a little bit shorter, it also sometimes when the values are very large or very small, you need to be very careful about how you do the math, and the folks who implemented that function in JavaScript have already taken that care, so I don't have to worry about it. So I'm just going to use that definition, and now I can replace this. So what is this? Distance. What am I doing? I'm just doing the distance between these two bounds, right, as points, basically. So that also makes this easier to read, because now we can sort of see what we're doing. Okay, we're looping over all these shapes. We're getting like the pairs of shapes. For each pair, we're getting all of the bounds. And in that case, we're doing all of the different pairs. And if the distance between those two bounds is less than 1, that's our threshold, I guess, for a collision, then we're pushing this object onto our array of collision points. And so that's already, I would say, a fair bit easier to read. So let's pop open our original. So here's the original with about 20 billion instances of cur shape or bounds check. Like there's just, I don't know. I mean, I made my point, I think. So I feel like this is easier to read. Just as a matter of convention, I'm going to take this comment, which is a good comment about what this function does, and it is in fact so good, we should put it up here. And typically, there's two styles of comments in JavaScript. I guess seen both, but sort of more important comments sometimes use this style. And so this is kind of a comment like this right before a function is going to generally be read as the documentation of what this function does. So now we have a function, we have the documentation for it, so someone who's reading this code can see, okay, collisions returns an array of objects that have an XY point of collision and the shapes involved. Okay. There's some other stuff I would do with this to make it a little, also perhaps, it's still a little, like the 4 levels of looping is, two is kind of the max in my book. And because it's really easy to get rid of extra levels of looping. So here's our 2 inner loops. We have 2 outer loops and 2 inner loops. So I'm going to I'll just cut that. I don't know what it's going to be called, but it's going to be a function. And it's going to do all the stuff that we did. And so and now the only thing we got to do to sort of stitch everything back together is we got to look at all the variables that are referred to in here and see which ones sort of came from the outside. And it's pretty obvious. It's S1 bounds, S2 bounds. Because S1 bound is defined right here. Oh, and collision points. Call it that. And then, so what is this really doing? This is like finding, or it's adding really to this array, add collision points. And so now we can go up here and say add of the S1 bounds, the S2 bounds. And so this, I don't actually have, I'm just editing this code. I don't really have a way to test it. So obviously in the real world, I would test this as I run the program and make sure everything's still working. Maybe I would even write some tests just for this function so I could run those tests very quickly without, this is presumably part of so much bigger program that might take a while to run and to see whether it's working right. But that looks, that's better in that now we only have to parse these 2 loops to understand, okay, this is following this pattern of pairwise combinations of these shapes, and then we're adding the collision points. Oops, we got to pass our array. And just also rename that. Points isn't quite right because they're a little more complex objects than points, but it's close enough. Sometimes you want to call it the same name as the function. Unfortunately, that's a little sketchy. It actually works in this case, but I like to keep them different. And then I would actually go one step further, and I would say, well, these 2 things about getting the bounds, I want to actually put that in here and then make this a function of the shapes themselves, like shape 1 and shape 2. And then I'm going to change this to be the argument shape 1 and this to be shape 2. So we get the bounds of the shape 1 and shape 2 that were passed in. And that means up here, we need to and now this outer method is very simple. It's like almost a classic. We have our accumulator, which in this case is an array. We loop this. It is a nested loop, so that's slightly more complex. But within the nested loop, we do exactly one thing, which is we call this function add collision points with the two values from the array that we're looping over, and pass along this points array so that add collision points can add stuff to it. I'll rename that to match up. And shapes S1 and shapes S2 are now, that's another sign that I did the right thing, and that this thing really cares about the shapes. It doesn't need access to the whole array, it just needs these two shapes. Shape, plural, shape 1 and shape 2, so there was a little dotted line there showing me that that name wasn't defined. And that seems pretty cool. So per my promise at the beginning, I didn't do anything that in theory you don't know how to do. Obviously, I'm guided by many years of experience doing this and knowing what kind of things make code easier to read and harder to read. Obviously, also some of that is just my opinion. You can, somewhat, you can make your own style, but I think you will probably find that more people will find this code easier to read than the original, and hopefully understand the reasons why. And so that's really it. I guess I think I'll just leave it there. Like, I don't need to go into, there's other things we could do with this code, but these are all things mostly just choosing slightly different names. I guess I broke out one function, and I could even, is it worth it to, not really. I mean, I could break this out as a function too, and then this add collision points would be a little bit shorter, but I think that's good enough. So just to swap back, here's the original. It is somewhat fewer lines, partly because I made this, spread this comment over 3 lines, and I added some functions and consequently some blank lines, but this is 28 lines versus 23 lines. These lines are all shorter. So that's about, it's not always about sheer lines of code. The levels of indentation matter a lot for sort of human understandability. And hopefully you see the point of all of this. All right. So thanks as always for watching, and I hope you got something out of it.